All right, 3.6, 10.3.6, review of index laws. You've done these to death. You've been doing them for years. You should remember all of these rules. Do you need to know which one's 1, 2, etc.? Not really. It changes depending on which book you read and what order you want to write them in. Law 1 and Law 2 are always the same. If you're multiplying two indices with the same base, you add the indices. If you have the same base being raised to an index with division or the quotient of two of those expressions, you subtract the exponents, the indices. A power raised to a power, it's the base to the product of the powers. Multiply the indices. If you have a product being raised to a power, you can raise each one of the power separately and then multiply them together. Law 4 and Law 5 are the same. We know multiplication and division are the same operation really. So here, where I've got A divided by B to the power of M, again, each one gets raised to the power separately. And finally, anything to the power of 0 equals 1, provided that that A isn't equal to 0, but that's another story. Let's just jump into a couple of the harder ones. The easy ones you've been doing for years you should have no problems with. Use appropriate index laws to simplify the following, so I'm just going to jump in and do it. Here, I'm going to simplify the top and then the bottom. Don't try and do it all at once. An extra line of work to make sure you get it right is well worth the effort. M multiplied by M. We don't worry about the W's for now. M's go with M's. 2 M's multiplied by another 3. That's 5 M's being multiplied together. W on its own, that's a W to the power of 1. W to the power of 1 multiplied by W to the power of 2. W to the power of 3. Divide it by M4 over W cubed. When you're doing division, you subtract. M to the power of 5 divided by M to the power of 4 is M to the power of 1. I don't need to write the 1. W cubed divided by W cubed. Well, we know that that simplifies to equal 1, because anything divided by itself is 1. Also, W cubed divided by W cubed, 3 minus 3 is 0, and that goes back to the 0 power. If I had W to the power of 0, it's always also equal to 1. So there we have it. M is the solution. Nice and simple. Let's have a look at the next one. Oh, I've got a few laws to combine here. 2m cubed all squared. Let's do that bit first. 2 squared, 4m cubed, being raised to a power. When you're raising a power to another power, find the product of those exponents. 3 2's are 6. Down on the bottom, it's 3, and that entire bracket to the power of 0. That's nice. That's going to simplify to 1. So it's really just 4m to the power of 6 over 3 multiplied by, let's have a look at this other side. Square the numerator. 6 squared, 36. Pen's starting to play up. Let's hope you can still follow that. I'm going to rewrite that one. Oh no, it doesn't want me to do it. Try again. There's more than one way to do this. Let's get out using the trackpad to do it. There we go. Should give me my pen back now and be alright. So 6 squared was 36. N to the power of 5 all squared. Product of those powers, n to the power of 10. Down the bottom, negative 2 cubed. If I take a negative and cube it, it remains negative. And 2 cubed is 8. N to the power of 3. Each one got raised to the power separately. M to the power of 4. Alright, we've got a product here. I can simplify common factors first if I would like to, and I like making my life easy, so I will. 3 goes into 3 once and into 36 12 times. 4 goes into 4 once and into negative 8 negative 2 times. Now I'm just going to simplify across before I simplify those thirds. Just multiply across first. So 1 by 12, I'm going to have 12 m to the power of 6 n to the power of 10. You could have simplified the m's and the n's as well, but I'm just going to do it in 2 steps. 1 by negative 2, so I've got negative 2 here, n cubed, m to the power of 4. You can see I was a bit lazy. I didn't cancel those 2's. 12 divided by 2 is 6. That negative I'm now going to put with the 6. It's going to make my life easier. So I've got negative 6. 6 m's on top, 4 on the bottom. That's 2 extra on top, so it's m squared. 10 n's on top, 3 on the bottom, so I can cancel 3 of them. N to the power of 7. So negative 6 m squared n to the power of 7. And we're done with that one. Have I got another one down here for you? Of course I have. Some of the more fun expressions here. Find the value of a in each of these equations in which the index is unknown. 2 to the power of a equals 8. Well, we should recall that 8 is the same as 2 times 2 times 2. It's 2 cubed. Therefore, a must equal 3. 3 to the a equals 81. Or 81. I could write it as 9 squared, or I could write it as 3 to the power of 4. So you rewrite the term on the right with the same base. Therefore, the indices must be equal. So a equals 4. Last one, 2 to the power of a plus 1 equals 4. So 2 to the power of a plus 1 equals 2 squared. The same base being raised to the power, they're equal. So a plus 1, the power on the left, must equal the power on the right, 2. Subtract 1 from each side, I get a equals 1. It's a few examples. You've done these before. Index laws, you should be all over them. Go and have some fun. See you in the next one.